Oh, hi guys, you are welcome to another video of mine. So we are into the day 3 of our physics topic by topic question and answer for UTMA and Waec students for 2022 exams. Apologies for my voice. I just want to follow the promises, like I'm going to make day-to-day videos for those that are writing the exam. Normally, I'm supposed to have a rest day today because of my voice. I'm doing this because I want the students to actually what? I want them to know that when you take something very serious, you are going to achieve it. So the topic we are into now is the topic of work, energy, and power. Like I said, you can tell a friend about this page and let them know. And if you find anything interesting after watching the videos, you can please or kindly please subscribe to our channel. So the first question is a ball whose kinetic energy is E. Kinetic energy is E is projected at an angle of 45 to the horizontal. The kinetic energy of the ball and the highest point of projection is dash. I think the concept of energy is texted here. Kinetic energy from junior classes is given as half mv squared. Excuse me, half mv squared. So now, if the body is projected according to the way the examiner told us that it was projected, let me just, projectile motion is a kind of parabolic motion you might have studied before in your junior classes. The body was projected with an initial velocity. I will take that. Let me say the initial velocity was u, and it's going to follow a trajectory path which you might have studied. You go up and come back to where it is starting from, like this. Now, during horizontal projectile, your teacher might have told you in classes that the distance of what projection is always what the same. So it is a two-dimensional plane with an angle of theta. But in this case, the angle is not theta. Maybe I write the angle value, it was 45. Sorry, we can resolve it to two components. This is the one, velocity as x, and the one up here at the highest point, I will take as a velocity at y. Now from this, when we resolve it, we say the one at the vertical component, that is y, is giving us uy is equals to the initial velocity sine theta, and the one at s is ux, is u cos theta. I hope you have studied this before in your junior classes, and if not, there is always a first time to everything. Need to say the angle is 45, so we are taking the initial velocity to be u. So that means at the highest point, which is the highest point, will be at this uy, this point now, which you can see diagram not drawn to scale. Maybe I clean that to have a good diagram. So at that point, let me try and bring a line that is very good. So that one is very good. At this particular point, we are going to have the kinetic energy at that point is what we are looking for. So from there, we can just substitute u multiply by cos or sine of, rather, sine is the y component, sine of 45. You need to know how to put values in short form. So this is a u times root 2 over 2, because sine 45 is root 2 over 2. So the velocity at this point is u root 2 over 2. So at the highest point, the initial velocity is this. So the kinetic energy at the highest point, which will now be kinetic energy, is now half. We consider the mass to be m as well, times the velocity at the highest point is this one. I'm going to substitute u root 2 over 2. By simplification, I'm going to get, this is a u root 2 over 4m. This is the kinetic energy at the highest point. But if you have checked the option, you are going to see that the answer is in terms of the E. So the kinetic energy, initial kinetic energy, was half mv squared, which I can say is you guys can check. This is like saying half times m. I'm using the v to be u. then you have U square. So initial kinetic energy is U square over 2m. I will continue from this side for you to get it. Initial energy is given as a U square over 2m, and that was said to be equals to E, and that is equals to E. The final energy is U root 2 over 4m. Then we now want to say, how can you get U root 2 over 4 from I said U, look at this, guys. Okay, have I square? Because I am supposed to square half mv square. You can see I have made a mistake because this is also a square. So if I've gone with that, what I'm going to have, my dear students, is going to be, you can see, I'm sorry about that. This is supposed to be a square. So look at this, it will be U square. I'm going to clean now because I hate doing rough work. It's because I'm taking you through the process. That is why it is taking time. U square, you can see, multiply. When you square this square, we remove this square root, multiply by 2, then over 2 square is now 4. Then you have times 1 over 2m. I forgot to actually cancel, and this gets cancelled out. So this energy is U square m over 4, or U square over 4m. That is the energy at the highest point, the kinetic energy at the highest point. Please keep it in mind. This is the value and not this value. So it's U square over 4m. So that's the kinetic energy at the highest point. And the kinetic energy at the beginning was U square over 2m, which is what I have here before. At the beginning was this, and now you just have to write it. There's something is lagging. My writing is lagging. I'm waiting for this to come up. I think it's back over 2m. So this is the initial kinetic energy. This is the final kinetic energy at the highest point. So it's now for you to relate this. You just need to multiply this one times 1 over 2. For example, U square over 2m times 1 over 2 will give you U square over 4m. So what I'm trying to say now is that the new kinetic energy is the same thing as what? The old kinetic energy multiplied by 1 over 2. I'm taking you through process for you to understand. So what we are saying now, and the old kinetic energy was taken to be E. So the new kinetic energy is just multiplying E, which was the initial kinetic energy, times 1 over 2. What is E times 1 over 2, my dear students? That is E over 2. So the answer to that is nothing but option C, which is E over 2. So sorry for wasting time on that. I want to take you through the process, and I know I want to use just 30 minutes for this video. Question 2 say that a force F acting on an object varies with distance, a force distance graph. As shown here, the force is in Newton and X is in meter. The work done by force in moving the object from X is equals to 0 to X is equals to 6. You can see it's the diagram. Now, for what we have also studied before under work, energy, and power, that for graphical work function, if you want to calculate work done in graph, it is always the area under the curve. Work done for graph is always area under force displacement curve or force distance curve. Be careful. So what you just need to do here is just to calculate the area under this curve. So the shape here is a trapezium. So the work done from moving it from 0 to 6, the area of trapezium from mensuration is half the sum of the two parallel sides multiplied by the height. So directly work done will be 1 over 2 times the first parallel side is 3 as the top, plus cross collaboration of my mouse. This is 6. The height is the height from here to here, 0 to 3. So directly we can just get answer 1 over 2 times 9 times 3 is 27. You can ask me how 3 plus 6 is 9. 9 times 3 is 27. 27 divided by 2, I think is 13.5 joule. And that should be the correct answer for that question. So this is also correct. So that is B for the second answer. I believe you can hear me. Like I said, permit me with my voice. We go to the next page for the third question. About the third question, excuse me, we have a body moves a distance of 10 meters along a straight line under the action of force of 5 Newton. If the work done is 25 joules, the angle which the force makes with the direction of the body is dash. Also, still under the topic of work done, which I think is one of the most simplest topic in your junior classes. So work done is also given as Fs cos theta of F dot product of x, which most of you are used to writing it as Fx, F cos theta. Let me just write it like this, multiply by what the displacement. So now, in this case, the work done was 25 joules, is equals to the force was 5 Newton, cos of that multiplied by the distance was 10. On simplification, we can say 5 times 10. 25 is equals to 5 times 10 is going to give you 50 cos theta. You make cos theta so the formula. So we can say cos theta is equals to 25 over 50. So 25 here 1, here 2. So you can say cos theta is equals to 1 over 2. Some of you like decimal point, which is same thing as 0.5 for Waec student. So you can say theta will now be what we call cos inverse, which is also called arc cos of 1 over 2. So from your special triangle in your trigonometry, for those of you doing maths, this is simple to know it that it is cos 60. That is equals to 1 over 2. So theta is going to be 60 as one of the answer for the what? For the question. So the answer is this, and I hope you understand Fs cos theta is another important formula you can keep in mind. Question 4. Sorry, like I said, my voice is very bad. I've been taking classes and it's really affecting me. Offline classes, and I shout a lot and trying to explain and stuff like that. So, but all the same, we are still trying to help those online to still gain more. So you have to calculate the kinetic energy, and this should be potential energy, and the potential energy of a ball halfway up. When a ball of mass of 0.1 kilogram is thrown vertically upward with an initial speed of 20 meters per second. Now, we have talked about work energy theory. And if you are yet to work the concept, you can still get something there. About work energy theory, what we are talking about there is just that work done by a body. Like, for example, work is a transfer of energy. That is the definition. That is, work can be converted to energy and so on and so forth. If object is thrown up or it is coming downward, say from potential energy, it has been converted to what? Kinetic energy. So many times, most of you are very good in getting this type of question, as you have talked about that the kinetic energy is converted to potential energy. In this case, because it is being thrown upward. So the kinetic energy is always half mv squared. But the only technicality here is that kinetic energy of the ball has been converted to potential. They are both equal. That is what I'm talking about. So halfway up will just be dividing your answer by 2. That is the only technicality here. Every other thing is simple. So directly, my dear student, let's get that. This is going to give us, you can see we are using one concept since morning. Half mv squared and for work done force times displacement, or Fs cos theta, or area under the curve. So directly we say half. The mass is given in this question is 0.1 multiplied by 20 squared, which is 20 times 20. I want to cut 2 here 1, 2 here 10. 0.1 times 10 is 1. 1 times 20 is going to give me 20 joules. That is the work done when this thing is finally brought to rest. So, but halfway, the kinetic energy is half. So you say, which is equals to potential energy. So kinetic energy halfway, which is equals to potential energy halfway. Let's see, will now be half of your answer. Halfway. I think it's a simple question. So that is 20 divided by 2. Each of them will be 10 joules each. And that is the question answer. So you go for choice B, which is the most correct answer. So that is the fourth question. We move to the fifth question. About the fifth question, we have if the momentum of a body is increased by 50%, wow, then the percentage increase in the kinetic energy is that. Still under the topic of work energy and power, this is still kinetic energy with respect to momentum. For those that have time to watch concept video, you can watch the concept video on this channel as well, where you can see how we come about all this formula. But for most of you doing the exam in few months, I think this particular kind of series is the best for you. Now, the kinetic energy is given in terms of momentum. This momentum is denoted by P. I have videos on conservation of momentum over, please be careful about this, over M. So this is the way we relate. So we say kinetic energy equals to momentum square divided by the mass. If you are seeing this for the first time, add it to your formula sheet because it's one of the newest patterns you see question in UTM. So now, how do you solve something like this? It's so simple. You can use your knowledge of variation for those that are also math students to get it. Now, let's say the initial kinetic energy, I'll take it initially was X. Then I'll call that E1. The new kinetic energy, E2, has been increased by 50%. From your knowledge of mathematics, increase something by 50%, it will give you 1.50x. For beginner, you can ask me, percentage are always in terms of 100. I don't want to waste your time. But when you increase something by value, you add that particular value to 100. So 50% increase simply means 100 plus 50. What's 100 plus 50? 150. Very good. 150 divided by 100 is 1.50. So that is how we do increase. So you have increased X by 50%, is going to give 1.5 of this. So what we are saying is that so far energy, kinetic energy, is proportional to the square of momentum. So we can say E1 over the first one over E, let me say, okay, rho 1 square or momentum square is equals to E2 over momentum of the second one square. So let's say the momentum of the first one, which is P, momentum is P, impulse is J. Now, momentum of the first one we take as Y. Then we are looking for the momentum of the second one, which we don't know. We take as question. They said momentum of a body is increased by 50%. What will be the increase in kinetic energy? Sorry, I am even increasing, instead of me increasing, let me take the first momentum here to be X. The second momentum was what was increased by this. So let's take the first kinetic energy to be E, just for you to see. I want to use the eraser. That is what I'm trying to do. The first kinetic energy, let's take it to be E. The second kinetic energy, let's take it to be Y. From this relationship, you don't need to waste your time. E1 over this one equals to E2, just square both sides. And if you go by that, X will cancel, but I can show you. My first is E1, this is E2, which is the one I'm looking for. Let's say the first one is E, the second one is Y. So the first, oh, wow. I'm using E1 over momentum square. This one is going to give me X squared. I just wanted to see the line of my thoughts process. E2 is Y, which I'm looking for. I'm looking for Y in this question over the second one is 1.50x squared. If you go by that on simplification, you can see if you cross multiply, you can say 2.25 is now equals to x squared is now equals to y x squared. As you can see there, students, you can see s squared gets cancelled out. So the new one, which was y, which is what I'm doing, the new kinetic energy is 2.25. So now 2.25%, because I'm working in terms of percent. Now, some of you will say there is no answer. Remember, I told you percentage are always taken in terms of 100. 2.25 is same as saying 225 over 100. Look at the way I'm thinking. It's because I have practiced a lot of questions and I know how to get answer. So 225 is as a result of what? 125% increase. If I say you should increase, you should find a 125 increase of what? Of a number. 125% increase of what? Of something, of this particular number. But when I say 125 has been increased, or a number has been increased by 125, what do you do to it? That means you add what? 100 to it. When it was increased by 50%, I add 100 to 50 to get 1.50. Now, for me to have 2.25, that means this thing, I will have to remove 100 from it, from 225. If I remove 100 from 225, I'm going to have 125% increase. So what I'm trying to say is that if somebody give me 1.50, I will subtract 100 from what? 1.150. I'm going to have 50. I'll say it means 50% increase. If I have 2.25, which is 225, I'll subtract 100 from it. I'm just trying to give you faster way. Then I'm going to know that, okay, 100 minus 225 is what? 125. That means 125% increase. Increase something by 125. That's 2.25. Because if you 125 plus 100, like from the method I've explained to you. So if the new value is 2.25, so that means it has increased by 125%, because from what I've just explained now, I hope students understand that. So these are simple things, these simple ways in which you can solve questions so that you won't have issues. The next question says, a ball is allowed to fall from a height of 10 meters. There is a height which is 10 meters. I'm thinking the way students think. So I don't want to make it advanced or technical. There is a 40% loss of energy due to air friction. Then the velocity of the ball when it hits the ground, velocity of the ball is the question. We talked about this now, that kinetic energy has been converted to potential energy. These are work energy and power concepts. Kinetic energy from junior class is half mv squared. I'm not supposed to be deriving anything. The formula is v squared equals to 2gh. I just wanted to say potential energy is mgh. On simplification, m gets cancelled out. So you have v squared equals to, I cross multiply, the 2 will come and marry the 2gh here. Or basically say v is equals to square root of 2gh, which is the way we solve for what? The velocity, because kinetic energy has been converted to potential energy. This is the concept. We are just repeating the same concept, and that is why we are taking it chapter wise. So for a particular section, it's all about a particular concept that you need to know. So having said that, the velocity when this is coming to the ground, you've done something like this before 2 times. I'll take g as 10, I'll take height as 10, it is given. So on simplification, v is equals to, we have this is 100 times 2. Hope I did not make mistake. 100 times 2 is square root of what? 200. So the velocity is square root of 200, but it is 40% loss. Like I tell you now, percentage are always in terms of 100. This is on the ground. If there is a loss of 40%, I'll just say 100 minus 40. What's 100 minus 40? That is 60. So 40% loss means is 0.60% of the value of the velocity of 200. So that's the interpretation of 40% loss of this value. So if you go by calculation, 200 times 6 is 1, 2, that is 120 meters per second. So what I'm saying is, this is the velocity when the body hits the ground, but because there is a loss of 40% energy, so remove the velocity will also what? Reduce. So if you reduce the velocity by 40%, this is the value we are going to have. So 120 meters per second is going to be the correct answer for that. So we move to the next one. Next question is, I think it's now question on power. How much water, that means the gram, that is the mass of water, a pump of 2 kW, which means kilowatts, can raise in 1 minute to a height of 10 meters. Take G to be 10 meters per second. So we want to know the amount of water, 2 kilowatts. We know that power, there are different types of power anyway. So if you talk about power, you can have what we call a variable power, and you can have instantaneous power. But for now, I am not teaching concepts. If you have any problem with that, you can watch the concept video. For power is a force times distance over time. Then instantaneous power can be integration or whatever, force times velocity, as distance over time is a velocity, which is a vector quantity. So that is now going to make the question simple. What we are going to do is that we have power in kilowatts. So you multiply by 1000. Power can also be in HP, horsepower. So which you convert, which is about 0.3 over 0.75, 0.76, whatever. So you convert kilowatts to watts. That is 2000. Power is 2000 watts. Is equals to, look at this now. Now, I think it's better to also write it for you that power is also equals to force times displacement is work done. So average power is work done divided by time. I think this is better. So we can calculate the work done first when we know the time. 2000 equals to what? The work done. Power is 2000 watts. The work done. You can see I'm doing it elementary, in an elementary manner, divided by the time. Time is 1 minute. I'll convert 1 minute to seconds. That's 60. So on cross multiplication, that's 2 times 6. That is work done is equals to 12. How many is there? 1, 2, 3, 4. 1, 2, 3, 4. That is the watt in joules. That is the power. Well, the question the examiner asked me for the amount of water. That is the mass of water. So we know that work done is force times distance. You can see it's the same concept. We are just repeating it over and over again. That is force multiplied by distance. Because of time, I have to be fast. The work done is 120 should be 120,000 equals to, now we are talking about weight now because I'm talking about height. So I'm converting this force to what? Weight. So force times distance now, I can turn into as what, taken as what, mg, or m times height. Force equals to, I'll turn the force to weight because there is a height. So what I want to do here, the force, I'm turning to weight, the weight multiplied by the distance. So the weight here is mg, which is the force, multiplied by the distance. I'm looking for the mass. The g is 10. The distance is the height. So mgh now, the way you write it in junior classes. You understand? mgh. So I just want you to know distance height times 10 is equals to 120,000. So on simplification, I can cancel this 0, cancel 1 0. This 0 also cancel 1 0. So what I have here is now 1200 is equals to m. So the amount of mass required by this body is 1200 grams or 1200 kilograms by mass. So this is the way you do power when it is what we call work done over time. So power can be work done over time, and power can be what? Force times velocity. Like I said, variable power and instantaneous power. Those are the two types of power you have. For more understanding on this concept, you can watch the concept video on work energy and power on the channel. Then the next one is going to be the engine of a vehicle. The engine of a vehicle delivers constant power. I love that. If the vehicle is moving up an inclined plane, then the velocity is that. Now, power is constant. Constant power. Force is what? Constant. We have said that power, or constant power, power equals to what? Force times what? Velocity. So from here, so you can say power is directly proportional to what? Velocity. So at every instant of time, if the power is constant, I get in it, That means we are talking about not a variable power now. So we are talking about what? A constant power. So that means the value of the velocity will also be what? Constant from this relationship. So my point is, like I said, you can have different type of force. I told you in physics, when forces are variable, you go for integration. That is just the basic idea. But here, power is proportional to velocity. So this type of power is called instantaneous power. So average power, which is work done over time, does not depend on velocity because velocity is constant. So when velocity is constant, then what? When power is constant, we say velocity is constant, as power is also proportional to velocity. So the answer to this one is that its velocity will also remain constant. I hope you understand the illustration about that one. So I think we have one more lap to go, which is the ninth and the 10th question. So about the ninth question, we have a body projected vertically from the earth reaches a height equals to the earth radius before returning to the earth. So whatever, let's see. The power exerted by the gravitational force is constant or is greatest. Okay. I think I did something like this in question one. The power is greatest at dash. Now, we said just now that power is equals to work done over time. And power is equals to force times distance over time. Right? Now, from here also, as distance over time is velocity, body is projected upward and reaches a height. So the way I've written this the other time, I say power equals to, you can also write it as mgh over time. You can see we are basing all these things on a particular concept. So it can be concluded or inferred that power here is proportional to the distance or to the height, a direct relationship. I'm using formula because I think that is what most of you like, to use formula to what? To get answers. And I will use it to get your answer. But normally, let me say my word, normally, you should always understand that what here, power is proportional to height. So the moment you release that particular body from the earth, or it's thrown vertically from the earth, now the moment as the something goes is trying to move up, as it's trying to cover a distance, so the power is also trying to increase. So they said the power exerted by the gravitational force is greatest. The moment the height is increasing, what do you expect? The power is also what? Going up. So this is the methodology that you just need to keep in mind. It's a simple stuff which you all can do. So always keep that at the back of your mind. That's what the power that is exerted by a body is a dependent of the distance. So at the moment the body is leaving the earth, you expect the power to also what? To do what? To increase. So they said the power exerted by the force, gravity is coming down. It's greatest by what? At the highest position of the body. No. It is not until the body reaches the maximum. In fact, if it reaches the maximum, the work energy theorem comes in. The power has been conserved. I said the energy has been conserved, then you can start saying, but we're talking about power. Power is independent of distance or height of the body. Look at option B, at an instant just before the body hits the earth. That is it. What goes up must come down because of gravity. You have learned that. So the moment the body just at an instant just before the body hits the earth. So at an instant you release it. Like I said, the body is what? No, look at this one. At an instant just before the body hits the earth. That is very wrong too. No, it is wrong. I told you the power increases at an instant as that thing starts growing. Because power increases with what? With height, as you can see from formula. It remains constant is very long. Then we have this one at the instant just after the body is projected. So the moment you project the body, the power of the body tends to increase. We call that instantaneous power. At an instant of time, you expect the power to also increase. So the last question for today, I was able to use the 35 minutes that I said I'll be using for all questions. Hopefully, I'll be able to use that. A body of mass 10 kg moves with a velocity of 2 meters per second along a circular path. Oh my word. When a body is moving along a circular path, the only technicality in this question is for the student to know that when body is moving along a circular path, are you guys here? The body is moving at what? Constant velocity. And power is a factor of velocity. Look at the question. When body is moving along a circular path, what happens? It is moving at constant velocity. And when body is moving at constant velocity, what do we say? It's moving along the circle, it's moving at constant velocity. when you are now to calculate power, power is independent of velocity. Power is equals to force times velocity. We've talked about the concept as force times distance over time is what? Velocity. Now, power, you understand that anything that's based on a circle revolving around it is always tangential to the circle. I hope you have studied that also. So since power is equals to force times velocity, variable force now, or you can see force times velocity. So, and velocity of a circular motion is constant. So if velocity of circular motion is constant, there's nothing to do. So that means that there is no power in this one. Power is equal to zero watt. So that's because velocity is what? Is constant. So there is nothing you are calculating that you want to calculate 10 times 2 times, no. You can't calculate the power because velocity of a circular motion is what? Is constant. So far velocity is constant. So we say the power is what? Power is equals to zero. So keep that at the back of your mind. The answer to that is zero because it is moving along a circular path. No power is what is being used when a body is moving along a circular path because velocity is constant. So, guys, this is where we stop for today, which is on the concept of work, energy, and power. Tomorrow, by the grace of God, is another day for the day 4, where we are going to look into the next topic. I think that should be concept on gravitation, simple machine, and elasticity. Just 10 questions for this first set until we finish all the topic in the syllabus. So see you soon. So don't forget to like and subscribe to this channel. Bye for now, and thank you.